Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Dear students, how are you all? Dear students, I welcome you in Pakistan International School Types Virtual Learning System for the session 2020-21. And as you know, this is your science class for grade 6. Dear students, we have started chapter number 10 in the previous lecture, and we have studied about the properties of light in that, like light transmitted, absorbed, and reflected from the surfaces. Then we have seen smooth and rough surfaces, and then we have seen some laws of reflections and some terminologies related to the law of reflection. Today we will see the topic related to the previous lecture, that is image formation by plane mirror, because plane mirror is used to reflect the light. And we will see the ray diagram for light reflected from a plane mirror, and then we will see reflecting surfaces. So let's get started. Yes, dear students, we have seen in the previous lecture about smooth and rough surfaces. So as we know that light is reflected in equal angle, same opposite direction, sorry, in in the plane mirror. So a shiny surface is called a mirror. So it can be a metal plate, it can be any stagnant water surface, it can act as shiny surface because we can see a reflection in that. And plane mirror also, like we use um, in our home to look ourselves. So a plane mirror has the smooth and flat surface, we know that, and we see images in a plane mirror when light reflected by the mirror enters our eyes. So we use plane mirror to see our faces, like light reflect come this way, and then it strikes over there and come into our eyes, so we can see our image in the plane mirror. So while using the plane mirror, we can observe some of the terms, like the image formed by a plane mirror is upright or straight upright. Do you know that the plane mirror which you see, that is upright? Yes, because you cannot see your image like your head is down and legs are up. Isn't it possible? No. You image formation in the plane mirror is upright, always upright, like the object is standing in front of the plane mirror. Number two, the image is equal in size to the object, so you can see here. So the next image, if is equal in size to the object. If you see the girl is standing here, it is having how much height she is having. So the same height you can see in the mirror, so that the size is equal in the image which is formed in the plane mirror as well as the real object. So number third, that image is laterally inverted. What does it mean, laterally inverted? What lateral means on both of the sides, the image is inverted. You are raising your right hand up, but you can see in the mirror your hand is left. Yes, if you can see, like that's why it's called mirror image. Like if you are using your right hand or your right side, you can see that right side in the mirror as left side. So that is called laterally inverted. Number four, the image in the plane mirror is virtual. It means the image disappears or on removing the object. Why it is so? That your reflection or your image is formed at the back of the mirror. At the back of the mirror means on the other side of the mirror, not on the same side where the object is standing. and it disappears when we remove the object from the mirror. So that disappears, the image is disappeared. That's why it's called virtual image. Opposite of that is real when we take that in the screen, on the screen. That's why it is called the real image. So the image is as far as behind the mirror as the object is in front of the mirror. You can see how much distance you are having in front of the mirror. So the same distance you are having at the back of the mirror um, while you are standing there. So you can see here, when we just move the object anywhere near the mirror or back of the mirror, so you can see the distance of the image is the same as the distance of the object. So where the object will go, the image will move at that side. So it means the image is as far as behind the mirror as the object is in front of the mirror. Dear students, now we are having an activity regarding this image formation on a plane mirror. So here there is a ray diagram. Ray diagram for light reflected from a plane mirror. This is very, very important to understand. Okay, ray diagram means that light travels in rays. So when these rays or these lines of the light travels and we represent those lines diagrammatically, so that is called a ray diagram. We represent those rays of light in the form of lines, so that's why it's called a ray diagram. So this is for plane mirror, so that's why it's called a ray diagram for a plane mirror. So let's get started. So what you have to do first for a ray diagram for light reflected from a plane mirror, you have to take a white paper and a drawing board. You have to adjust that white paper with the pins on the drawing board, fix that out. Then first of all, you have to draw a line. You have to give the name M on one side and R on other side of the sheet, like of the line. Then you have to put a plane mirror here on the line. For example, from here up to here, there is a plane mirror. Then you have to fix an object, any type of object, but for the because we are doing this activity with the pin, so we will put a fix a pin that has the name O, that serves as the object in front of the mirror. Now what we do, we will view its image, because so definitely the image will be formed at the same distance on the other side of the mirror. Okay, what we'll do now, we'll see the image from the left side of the object and we will fix two pins here where we can see the image of that object, that image I. So we'll put pin P and Q in such a way we will fix two pins on the right side. We will see the image from the right side, and then we'll fix two pins T and S over there. So from both of the sides we can see the image at the same distance, and how that is the same distance we will see right now. Okay, now we will remove all the pins and put cross like here, and remove the pins P and Q, but write the names and remove the pins from here. Then we'll put cross so that we can draw the line, straight line over there. Draw lines P, Q and ST beyond the mirror line MR like this one, P, Q up to here, and the straight one towards the I. The same line, like it means that it has to join the image of the object. And then we will draw the same line exact on the other side where we have S and T pins. This is normal. We'll draw normal here. Normal is in the center of the mirror. That is an imaginary line. Then we will join the point O, like where we put object O up to this line here, and again from O to this point here it is A, and here it is B. So we will join the line of from P, Q, and A on the line M, R, and then we'll join the same way A to O. And like this, we'll join T, S at the point B on the line M, R, and then the same from point O to B. You can see the direction of arrows because these are the incident rays. Incident rays, the rays which are reflecting, light is reflecting through the object up to the mirror and then coming back into the eye. These are reflected rays, these are incident ray. So you can see them from the arrows. Okay, so here these are the normals which are drawn on at point A and B, and you can see the distance of the object from the mirror and the image from the mirror with the scale. You can measure it, as well as you can see these angles. This is called angle A, which is incident angle, and this is angle of reflection. Both are same angles. Likewise, here measure the angle with protractor. Here the angle B, this is angle of incidence, and here B again, or you can write B prime because that is angle of reflection. So angle of incidence and angle of reflection are both are same. So here we have drawn the ray diagram of light reflected from a plane mirror. Now, do you know that the word ambulance, have you seen written the word ambulance, which is written literally inverted in front of the ambulance? Why it is so? Because this writing will appear straight when we see from our the mirror from here, from our car side mirrors of the car, so we can see the image properly that ambulance is written. So it is in real, it is literally inverted, but in the mirror then it will be inverted again, so it will be the straight writing. So then we will give way to the ambulance because that is emergency situation. Yes, dear students, now we'll see some of the objects and instruments through which the light is reflecting and pass in a straight line. So we know that light travels in a straight line. So very important device which is used to prove this fact, that is pinhole camera. And if you know that pinhole camera, you might have studied in grade 6. It is invented by Ibn al-Haytham. Ibn al-Haytham was the Muslim scientist who searched a lot and having the lots of invention on physics, especially light. So how this pinhole camera is constructed, you can see it's very simple. It is having the cardboard or a metal box with a pinhole in the middle of it. Look, you can see here is a black film all around. You have to cover it. These are some pieces of that box. At the back, there is a film. That is a film which is pasted here, and in the front and that cover, we just do pinhole here. So there is we paste an aluminium foil and just pinhole here, and all around you can do the black paint or black covering, so that light cannot penetrate or reflect or absorb inside the box. So light will just move through this hole inside this box, and make the image on this film. So the image which we got, that is real here. And uh, then you can see a pinhole camera. That is very simple. Put a candle over there, and the light from the candle, it makes the image over there in at the back of the box, which is having the screen over it, and but that is literally in what sorry, upside down. How the pinhole camera is having the image formation. So when we place a bright lit object, any object in front of the pinhole camera, an inverted upside down image is formed because light is traveling from uh, this hole. You can see light is striking here and just move through this hole, and it makes the image upside down. This is aperture. Aperture means hole. The lights are striking here, and then they pass into the hole, and at the back of the screen, then you can get the upside down image. So the image is real as it can be obtained on the screen, and then we just develop that into our photographic lab, and then we can have printed on the screen. So that is the first invention and the basic of that concept, that now we are using our digital cameras or all type of cameras which we are using. So that are based on this concept of pinhole camera. Now we will see some comparison of images formed by plane mirror and pinhole camera. So number one is a plane mirror forms a virtual image. Like we can see this is a plane mirror, so that forms a virtual image. It means we cannot get it on the screen. When we remove this object, the image will be removed because it is formed at the back of the a mirror. A plane mirror forms the image which is equal in size. Okay, so but what pinhole camera, it is we get a real image from that. A plane mirror forms the image equal in size as the size of the object. We will get the image of the same size, but in pinhole camera, the image forms the enlarged image or diminished image, like the smaller image we can get. The image formed by a plane mirror is upright. You can see upright, the same as the object, but in pinhole camera, the image is inverted. So an image which we can obtain on a screen is called a real image. Like this, we can take a photograph from the mobile camera or for any digital camera, any type. So we can just print on the screen of that real image. But the image which we can get from, which we cannot obtain on the screen like that, this is the virtual image. Like we remove the objects, the image will also be removed. Now we are having some reflecting surfaces and their uses. So reflecting surfaces help to change the direction of light in many optical instruments. We use them like periscope, telescope, microscope. We'll use, first of all, we'll see periscope. That helps to see on the other side of the wall as well, and we can make a periscope very easily. The simple periscope is having just a long tube like structure like this, And here we place two mirrors. Plain mirrors are used here, but at 45 angles. So we see from here, so light striking on the object and comes in this direction and just change its direction 45 degree, then strike over there and reflects back into our eyes. So if here is wall, so we can see up on the wall. So we can use the periscope in submarines and in battle tanks also. Like on the other side of the wall, we can use periscope to see this one, and we can use this one to see in the submarines and battle tanks also. So the crew inside the submarine and battle tank, they can see from inside, out of the tank and submarine, everything which is going on there. Now we will see another instrument or another device which is where we use reflection. So on plane mirrors, that is a reflecting telescope that produces the image of the distant objects like moon, stars. For astronomy, we use this type of telescope. We see from here. This is eyepiece, and you can see eyepiece lens is there. So what happens, the light comes from here, lots of light rays comes, incident rays just fall on this mirror. This is also objective mirror, that is plane mirror, and then reflecting to again on the other mirror which is at the diagonal um, form, and the like light ray strikes over there and then reaches into this lens, and lens is used to increase the size of the image, so we can see from here. So here the reflection is also used. Now you'll see another way of using reflection, that is a microscope. Here is a mirror, which is a plane mirror, which is used to reflect the light which is coming here, strike over there from the specimens is placed here, and through this specimen background, this is placed on the plane glass, so light can transmit from here, and then one, two, and lots of lenses are there through which the light passes, and we can see the smaller object into larger size, because these lenses are used to to make the image bigger. We have this microscope in our labs. Inshallah, we will see this one when we go to school, and as well as you have seen, might be in the previous classes also. Next one is multiple reflection is also very useful, and we use it for a purpose to make the kaleidoscope. Kaleidoscope is actually an optical instrument that is used for the toy and for a relaxing purpose. Here we can use the changing patterns of a simple design. What we do, that is a hollow tube in which we use three mirrors, one, two, and other side three, like one, two, and other side. This is a triangle, so on the three sides we use plane mirrors, long rectangular plane mirrors, and we just fix them in the angle of 60 degree or 45 degree, and then we fix them with the tape, like masking a scotch tape. Then we cover this with the beautiful designs. On one side, there are two plates on both of the sides. One is made of clear glass from which the light is reflected, and the other is ground glass. In clear glass, closer to the eye, sorry, in clear glass, it is closer to the eye. Small pieces of the color objects, any leaves or any color objects are placed in this one between the uh, two sides of. So what will happen? How does it work? So the plate of the ground glass, for example, this is ground glass. Ground glass means which is rubbed with some strong thing like sandpaper, and we make it not so clear. So what happened through this? The light is reflected, and in that there are beads and colorful. pieces are present. So light reflected through this mirror and just strike with the pieces this direction and strike with the piece in this direction. So these are multiple reflections, and when we turn this and rotate this kaleidoscope, so what will happen on the other side from the eyepiece, we can see the colored pattern, changing pattern, which you can see here in this image. So that is used to make lots of, not one image, lots of images by the reflection of these three mirrors are formed in the kaleidoscope. So my dear students, that's it for today. I'm sorry for taking too much time, but we have to complete this topic. Then we will see our types of mirror in the next lecture, inshallah. And I hope you understood it well, isn't it? That's very easy. And wish you all the best. We'll see you in the next lecture. Allah Hafiz.